All right, so now I wanted to look at an example in which we don't have a 0 on the right-hand side. Now, if we try to do this problem as is, we lose a lot of our tricks. Now, we are only able to look at just positives and negatives because of the fact that there was a 0 on the other side. We're only allowed to talk about solutions and critical values as being the top and bottom because of the fact that there was a 0 on the other side. So not having a 0 on the other side takes away a lot of our tricks. So what I would do if I were you is I would rewrite this until we do have a 0 on the other side. So what I would do is I would start off by subtracting the 3x to the other side. Now we also don't have a single fraction on the left-hand side, which was also necessary. So the next thing that I would do is I would find a common denominator. So I would multiply by x plus 4 over x plus 4. That gets me x minus 3x times x plus 4 all over x plus 4, which I could then distribute my negative 3 across to get negative 3x squared minus 12x over x plus 4. And then I could combine like terms to get negative 3x squared minus 11x over x plus 4. And if I want to be a little bit tricky, I could go ahead and factor out a negative x from the top, which would leave me 3x plus 11 over x plus 4. All right, so I did a whole bunch of work to get this into a pretty form. Once I get this into the pretty form, it's just as easy as any of the rest then. We're going to have solutions. We're going to have critical values. Solutions are what make the top equal to 0. Critical values are what make the bottom equal to 0. Critical value is negative 4. Solutions are going to be 0 and negative 11 thirds. Now, negative 11 thirds is about negative 3.6 repeating. Now, I point that out so we put this on the correct side on the number line. That it would go negative 4, then it would be negative 11 thirds, then it would be 0. Now my solutions were my solutions were closed because of the fact that we had an or equal to in them. My critical value is an open circle because they always are. Now I would go ahead and test x equals 1 in this case. I would always test a positive number. Don't test a negative, because if you plug a negative in, then all of a sudden you get signs everywhere. So as I plug x equals 1 in, I really have two parentheses on the top. I didn't write the negative x in parentheses, but it really should be. So if I plug 1 into that, negative x would be negative 1, which is a negative. If I plug 1 into 3x plus 11, it's positive, and 1 plus 4 is positive. So the whole thing's negative. Negative numbers are smaller than 0, and therefore I should shade it. I'm going to alternate, so I'm not going to shade there. I am going to shade there. I'm not going to shade there. So that I have from negative 4, not included, up to negative 11 thirds included, 0 included up to infinity. And remember that your infinities are always in parentheses because they're ideas, they're not numbers.